Hello everyone, and welcome back to the Fluctus Channel. A United States Navy destroyer at sea is built to move fast, fight hard, and protect a larger force from threats above, on, and below the surface. The modern Arleigh Burke-class destroyer is about 510 feet long, displaces around 9,000 tons depending on its variant, and carries radars, missiles, torpedoes, guns, electronic systems, helicopters, and a crew trained to react before danger becomes visible. It is not only a floating missile platform, it is a maneuvering machine, able to turn, accelerate, slow, and reposition inside a formation where seconds can decide whether a threat is avoided or absorbed. Ship maneuvering drills teach the crew how the destroyer responds under pressure. On the bridge, officers and helmsmen follow commands for course, rudder, speed, and formation position. In the Combat Information Center, watchstanders track radar contacts, sonar reports, navigation data, and tactical messages. Engineering teams monitor propulsion load, temperatures, alarms, and steering systems. A destroyer cannot drift or turn like a small boat. Its mass carries momentum, and every order must account for speed, sea state, nearby ships, and mission limits. During maneuvering practice aboard ships such as USS Chosen, the crew repeats controlled turns and speed changes, so everyone understands how the hull reacts before the same motion is needed in a real threat situation. The so-called drift technique used in torpedo evasion is best understood as controlled ship handling, not a stunt. When an underwater threat is reported, the ship may change course and speed while using decoys and sensors to complicate the torpedo's track. The turn throws the stern and wakes across the water. The hull leans into the maneuver, and the bridge team watches heading, speed, and stability while combat teams update the threat picture. The goal is to break predictability. A torpedo that expects one course is forced to adjust, while acoustic countermeasures try to pull it away from the real ship. From outside, the movement can look like a violent slide across the sea, but inside the ship it is controlled by commands, instruments, and practice timing. The helmsman responds to orders, the conning officer watches the ship's motion, and combat watchstanders keep feeding information to the bridge. Watchstanders make that possible. Lookouts scan the sea. Sonar teams listen below the surface. Quartermasters monitor position. The officer of the deck coordinates with the commanding officer and combat team. Orders move quickly, but the reaction remains disciplined. A rushed turn, misunderstood command, or late report can create danger for friendly vessels nearby, especially when several ships are operating in formation. That is why drills repeat the same language until it becomes a habit. Destroyers are not only defensive. Arleigh Burke-class ships carry vertical launch cells for missiles, a 5-inch gun, close-in weapon systems, machine guns, and anti-submarine weapons. During live-fire events, gun crews and combat systems, teams verify safety arcs, target data, communications, and firing permission before weapons engage. The 5-inch gun can strike surface or shore targets, while CIWS provides a last line against incoming threats. These weapons make the destroyer both shield and spear. Inside the ship, maintenance keeps all of this ready. Sailors inspect lifelines, repaint worn surfaces, repair fittings, clean salt buildup, test equipment, and keep passageways safe. Life aboard is tight, noisy, and organized around watches, drills, meals, repairs, and cleaning stations. The destroyer's power comes from technology, but its survival depends on sailors who understand that every valve, line, sensor, and steering command may matter when the ship must turn sharply and live through an attack at sea today. Underwater threats are among the hardest dangers for a surface ship to face because they often arrive unseen. A submarine can hide below layers of water, use quiet movement, and fire torpedoes from a distance. Modern torpedoes may use acoustic homing, wake information, or search patterns, so a destroyer must detect the submarine, classify the danger, and react before the weapon arrives. Combating that threat at sea requires sonar, helicopters, unmanned systems, trained watchstanders, and ready weapons. Destroyers carry lightweight torpedoes for anti-submarine warfare. These are launched from deck-mounted torpedo tubes, often in triple launchers positioned where crews can safely load, inspect, and fire under command. During torpedo exercises, the process begins with safety checks and communications. Crews verify the training range, confirm the weapon status, check launch tube alignment, and coordinate with the Combat Information Center. The bridge, sonar, and weapons crews share the tactical picture before the order is given. Deck personnel follow strict handling rules because training involves heavy equipment and ship motion. When a torpedo is fired against a submarine target, the destroyer is not simply shooting into the ocean. Sonar data, target motion, range estimates, and environmental conditions guide the attack. Water temperature, depth, salinity, and bottom shape affect sound. So anti-submarine warfare is part science and judgment. Once launched, the weapon enters the water and begins its search or attack profile, forcing the submarine to defend itself, maneuver, or leave the area. In exercises such as Torpex, crews gain confidence that their systems, commands, and safety procedures work under shipboard pressure. Other deck weapons give the destroyer flexibility against surface and air threats. The 5-inch gun can fire rapidly against surface targets or land objectives. The close-in weapon system uses radar and a fast-firing gun to defend against missiles or close threats in the final moments. Machine guns and small-caliber weapons protect the ship in restricted waters. Live fire exercises bring these systems together. Every weapon has a role, but against underwater threats, the most important advantage is coordination. The ship must find the submarine early, pressure it with sensors and aircraft, launch weapons when required, and keep moving before the torpedo becomes the only problem aboard. That is why torpedo defense is never one button or one maneuver. It is a race between detection, decision-making, and disciplined action. Preparing for submarine threats requires more than equipment. It requires training with ships, aircraft, submarines, and allied crews acting in the same ocean. Anti-submarine warfare exercises teach teams how to search, classify, track, and attack a hidden target while protecting friendly ships. Exercise Dynamic Manta in the Mediterranean and Exercise Dynamic Mongoose in the North Atlantic are built around that challenge. They bring NATO ships, submarines, maritime patrol aircraft, and helicopters into realistic scenarios where the enemy is difficult to see. These events matter because a submarine threat rarely announces itself. It may appear as a faint sound, a brief contact, or a pattern that only trained operators recognize. Training begins with planning. Commanders assign search areas, communication procedures, safety rules, and objectives. Surface ships listen with sonar, aircraft drop sonobuoys, and submarines practice both hiding and being hunted. The goal is not simply to find one contact. Crews must distinguish real signals from background noise, merchant traffic, sea life, and changing water conditions. Helicopters give the surface force a longer reach. They can move away from the ship, lower dipping sonar, drop sonobuoys, and carry lightweight torpedoes. During winter and maritime training events, helicopter crews practice launching, searching, reporting, and returning to the ship or landing zone. Their ability to cover water quickly makes them one of the most important tools against submarines. Exercise Dynamic Mongoose highlights how complex the hunt becomes in northern waters. Ships and aircraft work together while submarines exploit depth, temperature layers, and rugged underwater terrain. A contact may appear briefly, fade, then return from another direction. Each report must be checked before a commander commits weapons or maneuvers the force. This is where battle preparation connects directly to torpedo defense. A destroyer that has already trained its sonar team, bridge crew, helicopter detachment, and combat information center can react faster when a real threat appears. The dramatic turn at sea is only the final visible movement, after operators have already built the underwater picture. The real battle begins earlier, in the patient search for the submarine before it fires its weapon into the water. The future of torpedo defense also depends on machines that watch the ocean without putting sailors directly in danger. Unmanned surface vessels such as the Manta's T-12 can patrol, scout, and collect information across coastal or open water areas. A small unmanned craft can move ahead of larger ships, inspect suspicious zones, and extend the eyes of the force beyond the deck. It gives commanders more places to look before danger closes. During unmanned system demonstrations, operators prepare the craft, test communications, confirm sensor feeds, and launch it into the water. The craft follows routes, while cameras and sensors transmit information back. Common Unmanned Surface Vehicles, or CUSVs, expand that idea. They can support mine countermeasures, surveillance, and testing without requiring a crew on board. Operators monitor the vehicle remotely, adjust its mission, and recover data after the run. Underwater unmanned vehicles add another layer. These systems can search below the surface for mines, obstacles, or unusual objects using sonar and programmed routes. Operators launch them, track progress, recover them, and review the collected data. They are especially valuable in mine surveillance, where sending divers first could be too risky. By pushing sensors into dangerous water before sailors arrive, unmanned systems help build a clearer picture of what may be hiding below. Together, destroyer maneuvers, decoys, torpedoes, helicopters, allied exercises, and unmanned systems form one defensive web. The ship may perform a dramatic turn to escape a torpedo, but that moment is supported by years of training and technology. Watchstanders detect, helicopters search, torpedoes counterattack. Unmanned systems expand the ocean picture. Maintenance keeps the ship ready. In the end, the Navy's strange-looking drift is not a trick. It is one visible piece of a larger survival system designed to keep a warship alive when danger comes from below the waves. That is the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. Thank you.